Hi everyone, my name is Antonio Nelson. Currently a graduating senior. I attend Shore University and I also attend Wake Tech Community College as well. So yes, I'm a dual student. I'm a visiting student at Wake Tech. Um, I'm a student in the class of General Chemistry 2. So this video presentation is for that class specifically. And my video presentation will be entitled, or is based on the experiment, A Balloon in a Bottle. I chose to do this experiment because I feel like it's an experiment that I'm comfortable talking about, or even I'll be comfortable replicating. And I feel like I'm more comfortable explaining the chemistry behind this experiment that was pertaining to the coursework we did in class over the semester. To perform this experiment, there'll be a few equipments or materials that will be needed. And those materials or equipment that are needed to perform the experiment or task are a balloon, a needle, a plastic bottle, and some tape. Now, we watch approximately a 1 minute clip of the demo tape.
Blow up a balloon inside of a bottle. First, stretch out the balloon. Once it's all stretched out, put the deflated balloon into the bottle and wrap the neck of the balloon around the bottle opening. Try blowing up the balloon. It doesn't blow up. What if we make a hole in the bottle? Now try blowing up the balloon. Careful not to cover the hole. It inflates. Quickly cover the hole with your finger. Seal it with some tape. You'll see the balloon won't deflate even though the bottle isn't sealed. Now try this. Take the tape off and let the balloon deflate. Put your mouth on the hole you made in the bottle and try to suck the air out like this. You've inflated a balloon without even touching it.
After careful consideration of this clip, I understood that there were a lot of science and chemistry behind the experiment. However, the forms of chemistry we see pertaining to what we did in class in the aspects of state of matter, whereas air pressure, vapor pressure was involved, equilibrium was involved, diffusion was involved, and concentration, just to name a few. In the experiment, forcing additional air particles from your lungs into the balloon, these particles hit the inside walls of the balloon creating enough pressure or force to expand the rubber of the balloon and causing it to inflate. The collision of these particles in the walls create a high pressure environment inside the balloon relative to the atmospheric pressure around it, which is the balloon in the bottle, but you still have inside the balloon and you still have outside the balloon, which is still inside the bottle. So this is why when the balloon is released, the high pressure air flows out to the low pressure air surrounding it. Think of it as we were balancing equations or even trying to create an equilibrium or equalizing. When a balloon is placed inside the bottle, it will not inflate on its own, since the bottle is already filled with air particles with no escape route. So this is a great demonstration that air takes up space, even though we don't seem to think so. The air inside the bottle compresses a little bit, but not enough to permit the balloon to inflate on its own. So when we take the pin or the needle and punch a hole at the side of the bottle or in the bottle, the air molecules in the bottle have like a escape route, which they are pushed out as the air inside fills up, resulting in room for the balloon to inflate. If hole in the balloon, the hole in the bottle is then plugged, or we take the tape and we tape it or cover it with our finger, even though the balloon still stays inflated even when our mouth is removed. This is because the high pressure air in the balloon pushes outward harder than the low pressure air in the bottle. The air in the balloon pushes out against the walls, keeping it inflated. When the hole is unplugged, air flows back into the bottle. The air pressure in the bottle increases and then causes the balloon to like deflate. So that's why I understood about the chemistry behind it. Again, my name is Antonio Nelson, and I kindly thank you all for being a part of my presentation, for watching at my presentation. And I'll ask that you guys please keep safe during this global pandemic. Stay blessed.